Welcome to this concept explainer, brought to you by CBSE ScoreLab of ProfSam.com. That is ProfSam.com. Today we are beginning our deep dive into Unit 11, focusing on the dual nature of radiation and matter. We're going to tackle one of the most, well, conceptually tricky parts, the photoelectric effect. And we'll see why it completely shattered the old wave theory of light. Our mission is simple, to make this so clear that you lose all your fear of it, guaranteed. All right, let's start with a simple yet a really puzzling question about light, something that puzzled the greatest minds in physics over 100 years ago. If you're using light to cause a physical change, let's say knocking tiny electrons out of a metal surface, what do you think matters more, how bright the light is or what color it is?
Sir, logically speaking, it has to be the brightness. No, brighter light means higher intensity, and intensity is all about energy. More power, it's just like turning up a heater, more wattage, more heat.
That is perfect classical intuition. And that is exactly where the universe told classical physics.
Well, that it was wrong. This is where it gets really counterintuitive. Imagine this specific scene. You have a very, very bright red lamp, super high intensity, and then a very faint, dim purple lamp. Now, the bright red lamp, it cannot eject a single electron, not one, even if you shine it for 8 hours straight.
It does nothing.
Absolutely nothing. But the faint purple lamp, it instantly ejects electrons.
Wait, what? A powerful bright light is useless, but a dim light works instantly, just because of the color.
Exactly. Why does the color, which is the frequency, completely trump the brightness, the intensity in this whole interaction?
That is genuinely shocking. It just goes against everything we learned about waves and how they spread energy continuously. If energy just accumulates, the bright light should have done much more. Precisely. And that's the crisis we're diving into. This thing exists because physics faced a fundamental problem. Light and matter, they just refuse to obey the simple, continuous wave rules. The core idea that resolves this, the absolute zero-level idea, is that light energy is not delivered continuously like a wave. It's delivered in discrete, tiny, individual packets. We call these packets photons.
Packets of energy.
Yes. And the crucial part is that the energy of each individual packet, each photon, depends only on the light's color, or more technically, its frequency. It's all in that famous formula, E equals high. So a higher frequency like violet light means a higher energy for each packet.
Okay, so the energy comes in packets, but why can't the metal just wait and accumulate the energy from many weak photons? If the bright red light has 1 billion weak photons hitting the surface, surely the electron can eventually collect enough energy to jump out?
That is the essential question. And for that, we use the concert door analogy. It explains why this accumulation idea fails completely. Think of the metal surface like a gate to a very exclusive concert. And this gate has a minimum height requirement for entry. That minimum height, that is the work function, or EVIS, of the metal. Now, the photons are the people trying to get in. If a photon, a person, is too short, meaning its frequency is too low, like our red light, it cannot meet the height requirement.
It doesn't matter how many of them are there?
It doesn't matter if 100,000 short people queue up. The guard checks each one individually. None can enter. Only a person of the correct height, the high-frequency photon, like purple light, can pass, and they pass instantly.
So the metal is like a very strict one-to-one guard. It checks every single photon, and it's an all-or-nothing interaction.
Exactly. To really get this mental image, think of the photons as powerful, discrete hammers raining down on the metal surface.
Feathers, okay.
And the surface is like a cliff edge. An electron needs a minimum energy, W, to jump off that cliff. Red hammers are individually too gentle. They're too weak to make the electron jump, even if 1 million of them hit. The electron only interacts with one hammer at a time.
But the violet hammer?
But a single violet hammer carrying enough energy instantly punches that electron right over the cliff. It's an instant one-to-one collision. This work function, W, this minimum energy, it's a common barrier for all electron emission processes. And we usually measure it in electron volts, or EV. Now let's get a bit more formal. We really need to understand the 3 fatal failures of the classical wave theory. This will show you exactly why the photon concept was, well, absolutely necessary.
Right. We need to know what the old system predicted to see why it was wrong.
Correct. Classical theory assumed light was a continuous wave, and it predicted 3 things that experiments, well, they flatly contradicted. Failure number 1 is about kinetic energy. The classical prediction was that since wave energy is proportional to intensity, a brighter light should give more energy to the electron. So ejected electrons should come out faster, with a higher maximum kinetic energy, Ke max.
That makes sense from a wave point of view.
It does. But the experimental reality, the Ke max of the ejected electrons, is totally independent of intensity. Whether the purple light was dim or bright, the fastest electrons came out with the exact same maximum speed. Ke max only depends on the frequency.
That's so strange. So turning up the brightness doesn't make the outcome more powerful.
Yeah.
It just makes more of the same outcome.
Yes, that's the core of it. Now, failure number 2 involves the threshold. Classical theory predicted that, given enough time, any light should work. An electron should just accumulate energy from the wave. So even with low-frequency red light, if you wait long enough, it should work. Which means a sharp threshold frequency should not exist.
But it does exist.
It absolutely does. Experiments prove that below a certain sharp cutoff frequency, there is NO emission, 0.
Even if you make the light incredibly intense.
Even then, this proved the energy transfer is quantized. The quality of the individual packet matters, not the total quantity offered.
Wow. So fail the frequency test and the flow of electrons is always 0.
Always 0. And failure number 3 is about the timing, the time lag. Classical theory predicted that an electron might have to wait, maybe hours or even days, to absorb enough energy from a dim wave to escape.
And the reality?
The emission is instantaneous. The moment you switch on the light, electrons are ejected. We're talking less than 10 to the power minus 9 seconds. This is only possible if the energy is concentrated in a particle that delivers its entire punch instantly. Hope everything is clear so far. We've seen the problem. 3 experimental facts that the wave theory just couldn't explain. This concept explainer is from ProfSam.com. That is ProfSam.com. So we have the crisis. We need a resolution. And the only thing that fits all 3 experimental results is Einstein's photon model. When he applied the law of conservation of energy to that single photon-electron collision, he derived the most important formula for this unit.
Okay, before the formula, should we get the formal insert definitions down?
Yes, good idea. Please read them out.
Okay. The phenomenon of emission of electrons by metals when illuminated by light of suitable frequency is called the photoelectric effect. The minimum energy required by an electron to escape from the metal surface is called the work function of the metal. And the photo-generated electrons are termed photoelectrons.
Perfect. Now, the equation itself, it's just simple energy conservation. The total energy brought in by one photon is high. This energy is used for 2 things. First, to pay the work function, and second, whatever's left over becomes the kinetic energy of the escaping electron.
Right, and that gives us Einstein's photoelectric equation. The maximum kinetic energy, Kmax, is equal to the photon energy, high, minus the work function. So Kmax equals high minus...
Exactly. Think of it like a transaction. High is the money you have, is the price of the ticket to get out, and Kmax is your leftover change. And for calculations, just remember that Kmax is also related to the stopping potential, V, by the formula Kmax equals E times VR. Now let's use this one equation to quickly explain those 3 failures of classical theory. First, the threshold frequency. Kinetic energy can't be negative, right? So emission is only possible if your input energy, high, is at least equal to the work function.
No.
When you set Kmax to 0, you get the minimum condition. High equals high. This instantly defines the threshold frequency. E equals over H. Contradiction resolved.
So the equation itself mathematically proves that the color test has to be passed first.
Precisely. Second, kinetic energy. Look at the equation again. Kmax equals high minus high. Kmax depends only on E, the frequency, and high, a constant for the metal. Does intensity show up anywhere?
No, it doesn't.
No, which confirms the experimental finding. Kmax is independent of intensity. Contradiction resolved.
Okay, so what does intensity do then?
Good question. Intensity determines the number of photons arriving per second. More intensity means more of these high hammers hitting the surface. More hammers mean more collisions, which means a higher photocurrent. More electrons come out per second. They will. And their maximum kinetic energy will be the input minus the cost. So the 2.48 minus 2.3, which is 0.18 eV. The electron escapes with 0.18 eV of energy. And the stopping potential, V, needed to stop it, would just be 0.18 volts. So it's a very simple energy balance.
Yeah.
And just to connect this idea of energy quanta E equals high is the thread that ties all of modern physics together. It directly connects to the next topic, atomic spectra. Those specific colors that atoms emit. That's just electrons jumping between orbits and releasing exactly one photon whose energy high matches the energy gap. It's all about quantized energy. Now, let's discuss the silent killers. The key misconceptions that students, they often fall for in exams. Be very careful about these 3.
Okay, this is important.
Very. Misconception number 1. The wrong idea is that the kinetic energy of the electrons increases with light intensity. Students think this because they confuse the total energy of the beam with the energy of a single photon.
Right, so they're thinking more power in the beam means faster electrons. I can see why that feels right.
It does feel right, but it's wrong. The correct idea is that Kmax depends only on frequency. Just remember our hook. Frequency is the gate, intensity is the flow. Brighter light means more electrons, not faster ones.
Okay, frequency is the gate, intensity is the flow.
Got it.
Misconception number 2. The wrong idea is that if the light intensity is super high, you can eventually eject electrons even if the frequency is below the threshold. Rubio.
I was just thinking about this. If I have a laser 1,000,000 times brighter than the sun, but it's red light, you're saying still 0 electrons come out.
0 electrons. The correct idea is that this is an all-or-nothing one-to-one interaction. If the individual photon can't do the job, no amount of other photons will help. So remember, fail the test of frequency and the flow is always 0.
Always 0. Wow.
And finally, number 3. This is a common graph error. Students sometimes plot stopping potential, V euro versus wavelength, and they expect a straight line.
Why is that wrong? They forget the inverse relationship. The relationship is linear with frequency. The equation is V equals H by E times minus W by E. It's a straight line against E, but since wavelength, E is C over, plotting against E gives you a curve. So remember, Einstein's equation uses frequency E. Plot V versus E for a straight line. Okay, let's lock this in with some memory anchors. To remember the 2 main defining equations of this whole unit, just remember this. E equals high for photons, and lambda equals H by P for all particles. Both are connected by Planck's constant H. And for the main concept, just internalize this phrase. Frequency unlocks the gate. Intensity determines the flow. That one sentence summarizes everything.
That's a great summary.
And you can try this visualization gesture. For Kmax equals high minus W, hold one hand high for high, the input energy. Hold your other hand at chest level for W, the barrier you have to pay. The gap between your hands, that's Kmax, the leftover energy. It helps you see that high must be above W. So to wrap up, let's summarize the core insights into 3 short exam-safe points. First, the photoelectric effect is the strongest proof that light isn't a pure wave. It consists of discrete energy packets called photons, with energy E equals high. Second, the core principle is Kmax equals high minus high. This shows that the maximum speed of ejected electrons depends only on the light's frequency, or color, and is completely independent of its intensity. And third, the existence of that sharp threshold frequency is the critical proof that light energy is quantized. Below this frequency, no emission is possible no matter what. To get maximum marks in 12th CBSE Physics, Chemistry, and Maths, visit ProfSam.com.
That is PROF Sam.
Right, yes. ProfSam.com. Study well, and we will talk again soon.